Blindness, death, skin cancer, and immune system problems, all of this would have gradually destroyed humanity if not for the planet's ozone layer. It protects us from deadly space radiation, or so we thought. In 2023, scientists from the United States published an article about a new type of supernova. The results of studying those giant stars were disappointing for all of us. Apparently, the radiation emitted by these supernovae can destroy our planet's ozone layer, and we won't even notice it immediately because the process will start years after the initial stellar explosion. But the worst part is that space is full of objects and phenomena that can cause mutations in us or even destroy humanity as a species. So, how can space kill us? If a supernova destroys the ozone layer and atmosphere, life here will be a living hell. Nothing confirms this more than planets that don't have such reliable protection against space threats. We're very lucky that conditions on Earth differ from those on Proxima Centauri b. When astronomers discovered this planet, they initially thought it could have water and life, but that was the wrong first impression. Proxima b is too close to its red dwarf star. One of the characteristics of such stars is their tendency to produce stellar flares every 2 to 3 months. When that happens, Proxima b receives 4,000 times the radiation that breaches Earth from solar flares. If our planet were in the place of Proxima b, a flashlight that would just melt a person. Another planet that suffers from proximity to its star is called CoRoT 7b. The star around which the planet revolves is 60 times closer to its planet than the Sun is to Earth, so sunrises and sunsets here look much more colorful than ours. However, that sight would threaten us with extinction. After all, due to this proximity to the star, the temperature on the planet's day side reaches over 2,500 degrees Celsius. That's enough to melt even a rock, not just a person. While one side of the planet has boiling oceans, the other has permafrost, with temperatures dropping to 200 degrees below zero. Even an attempt to take a breath in this part of the planet will destroy your lungs and cause instant death. Because of these two temperature extremes, scientists call CoRoT 7b 2 hells in one. Under such conditions, the water cycle with the evaporation of water and the formation of rain clouds and precipitation would also look different. On Earth, severe erosion would destroy solid rocks, which would rise up with water vapor and then fall as stone rain. Such a storm could fatally injure a person. More dangerous storms occur, for example, on the planet WASP 76b. Like CoRoT 7b, it has an ultra-hot day side and a relatively cold night side. But in this case, these swings form something more terrible than stones. Due to the duality of temperatures between the day and night sides of the exoplanet, violent winds blow on its surface, transporting iron vapor from the hot day side to the cool night side. At the moment of transition, the vapor cools down and turns into drops of iron rain. Imagine if chunks of metal fell from the sky to Earth. In just 1 second under such rain, something like hundreds of knives would pierce the human body. But what could be worse than that? The answer is life on HD 189733b. The temperature on this planet is also relatively high, but the reason for this is not just its proximity to its star, but also how fast the planet revolves around it. Each orbit takes only a little more than 2 days to complete, with an orbital speed of almost 153 kilometers per second, while Earth's orbital speed is less than 30 kilometers per second. Life on HD 189733b would be like a centrifuge ride that went haywire and caught fire. But the scariest thing is that this planet has hurricanes of glass fragments hurtling at a speed of over 8,500 kilometers per hour. Under such conditions, a person would be instantly cut into thin shreds as if dropped into a shredder. There is a planet where you can cut yourself just by walking around, and that's 55 Cancri e. At first glance, it looks incredibly beautiful and expensive, as its surface is covered in diamonds. In a word, 55 Cancri e is like millions of Tiffany & Company jewelry stores gathered in one place. But diamonds can become very sharp in the process of erosion and grinding. They're so sharp that they're even used in medicine on Earth, for example, for making scalpels. You'd cut your legs into bloody stumps after just a few steps on such a surface. But 55 Cancri e is better known for its ocean. You see, it's formed not from water but from red-hot lava, which can melt even iron. The same deadly hot conditions prevail on planet KELT 9b, which, by the way, somewhat resembles our own. Like Earth, it has 4 seasons, except there are 2 summers and 2 winters, each lasting only 9 hours. If such drastic weather changes suddenly appeared on our planet, the human body would not be able to quickly adapt to such sharp temperature fluctuations. Even changes in climatic and time zones after a long flight can result in a headache and fever. In short, seasons like on KELT 9b could even be fatal. But the list of planets that seek to kill you doesn't end there. Just this year, the James Webb Space Telescope detected a raging dust storm on planet VHS 1256b. In addition, the dust particles are silicates, something like small grains consisting of silicon and oxygen. This storm is not like our terrestrial ones, but more like a hot, rocky fog. If you were to encounter such rough weather, you'd get numerous burns and bruises. But we shouldn't hurry to rejoice that our planet has fewer threats. After all, the ozone layer won't protect us forever. We can't be sure humanity won't face another mass extinction. This has happened before. Scientists have long struggled to understand what could have triggered the Ordovician-Silurian extinction event, which occurred about 445 million years ago. It's among the top 3 in terms of the number of extinct species. It's the second largest mass extinction event, estimated to have killed the most living organisms. In the course of studies, it turned out that the secret of the Ordovician-Silurian extinction event lies in ancient geological deposits. In the deposits of that period, archaeologists have found a lot of a special kind of iron formed by interaction with gamma radiation. Scientists say that it probably happened like this: 6,000 light-years from Earth, a second hypernova explosion occurred. Even such a short time was enough for gamma radiation from the explosion of a supermassive star to affect Earth's ozone layer. At the moment it hit, the ozone layer became twice as thin, and when the planet's protection was reduced, all life on Earth was exposed to intense ultraviolet radiation. That space emission killed 85% of marine species. That scenario may repeat itself, but this time it'll affect us. After all, the ozone layer is gradually becoming depleted, and not only air emissions are to blame for this. The frequent launch of rockets or satellites into space is slowly damaging the planet's ozone layer, creating holes in it. That will make it easier for distant gamma rays to penetrate Earth's surface and for those relatively close to us to completely destroy the ozone layer. These bursts usually occur when black holes or neutron stars collide. Then, their magnetic fields join together and emit giant jets of energetic particles and photons. If a person gets anywhere near an object that emits gamma rays, they'll be instantly burned to a crisp. But even at great distances, such rays are capable of ionizing atoms and molecules, removing electrons from them, and breaking chemical bonds. In other words, if that burst reaches Earth and irradiates a person, their DNA will be damaged. This may even cause mutations and cell death. Nowadays, astronomers detect about 1 such radiation burst per day, and those are just the ones visible to our modern devices. But there is a particular space mission you can notice on your own without any equipment, but you won't be able to enjoy this sight for long. I'm talking about supernova explosions. When giant stars die in powerful explosions called supernovae, they temporarily become one of the brightest objects in the universe. One supernova can outshine the combined light of hundreds of billions of stars. If something similar happened within our solar system or relatively close to it, such a bright light would damage your eyes. After such an event, part of the world's population would suffer from cataracts, and the rest would go blind. How much worse could it get? Well, that's not all. Even supernova explosions aren't as powerful as the gamma radiation from magnetars. This is a type of neutron star with an ultra-powerful magnetic field that's 1,000 times stronger than your average neutron star and about 1 trillion times stronger than Earth. Magnetars, like supernovae, can destroy our planet's ozone layer, and they'll need only a few milliseconds for that. That's how long their bursts last, but this is more than enough time for them to release an enormous amount of energy. If a person ventured closer to a magnetar than about 1,000 kilometers, the magnetic field of the burst would tear away the electrons from the atoms in the human body. A person would end up converted into a cloud of monatomic ions, that is, single atoms without electrons. But while we are thinking over hypothetical scenarios with distant objects, outer space already has phenomena that are gradually destroying us right now. We all know that most conspiracy theories were invented by people who are far from science and adequate reality as well. But after NASA revealed some details about the Halloween mission, there was a reason to wonder, could the moon missions really be faked? You see, more than half a century ago, American scientists detected incredibly intense radiation relatively close to Earth. At first, they thought they had uncovered secrets of Soviet nuclear tests, but it turned out this radiation had existed near our planet all along. In 1958, astrophysicist James Van Allen determined that Earth is surrounded by two radiation belts. They look like giant donuts, and our planet is, so to say, in their hole. These belts result from Earth's magnetic field acting like a magnetic trap. It holds solar wind particles together and accelerates them within the belts almost to the speed of light. The sizes of these donuts vary depending on activity. The inner belt begins at an altitude of 600 to 1,600 kilometers above Earth and, according to various sources, extends up to about 9,600 to 13,000 kilometers. Likewise, the range of the outer belt varies from 13,500 or 19,000 kilometers to almost 40,000, and that's fairly close to us. So, particles falling out of the radiation belts can affect the chemical composition of Earth's atmosphere. Besides, during geomagnetic space storms, the density and energy of these radiation donuts particles may increase and pose a threat to terrestrial technologies. But the ones who can directly experience the belt's pernicious influence are, of course, astronauts. So, NASA's mission trajectory has always been designed to bypass these belts. After all, this radiation is even more harmful to humans than X-rays. The extent of damage to people may vary anywhere from zero to a fatal outcome. Therefore, when it was announced that the astronauts of the Apollo 8 mission were the first to pass through these Van Allen belts, conspiracy theorists immediately stated that the flight had been faked because such a serious organization couldn't possibly be so indifferent to the lives of its employees. And that's when it became difficult for society to choose the acceptable truth. Either NASA is completely inhumane, but they don't lie about orbital flights and landing on the moon, or all scientific discoveries are fiction, but at the same time, NASA doesn't jeopardize human lives. The organization immediately stated that the crew had been fully provided with all protective equipment, and the module was covered with heavy-duty materials, including radiation-blocking ones. But with all this, NASA admits it has underestimated the level of danger in low and medium Earth orbits, but is willing to spend more money on building more heavily shielded spacecraft. Let's just hope these guys are fully aware of their actions. Alas, threats from space don't end there, and you don't even need to approach the Van Allen belts to become their victim. In addition, everyone can predict the approach of the next space hazard. First, people in the northern latitudes will observe an astonishingly beautiful aurora. At the same moment, you'll notice that the internet's dead slow, then all mobile network subscribers won't have service, and after that, all the electronics will start to spark and break down, including the cell phone in your hand. All this will mean that right at that moment, the sun will be experiencing massive plasma emissions, causing elevated radiation levels on Earth's surface. Solar flares are usually emitted from the star's darker regions, cold spots, because the magnetic field strength is higher there. Now, let's take a look at one of the latest images of the sun. As you can see, it has plenty of dark spots, so we'll have to endure a lot of flares. The most powerful of them, X-class flares, occur once every 10 years. The most recent wasn't in 2003. It was so powerful that it overloaded the sensors measuring it. It even caused radio blackouts on Earth and space satellites for a few moments. I think it's easy to calculate when the next such powerful flare will happen. So far, the ozone layer is still protecting us from the strong impact of these cosmic emissions. But if it were damaged even more than it is now, a person would be exposed to so much radiation that they'd get skin cancer. But although such phenomena are hazardous for us, there's an object whose radiation is so intense that it can harm not only people but also the surrounding stars and planets. It's the ultimate galaxy killer. Can you hear that? It's not the sound of the underworld or Floyd's Echoes song. That's what the most hazardous object in space sounds like, a black hole. This particular one is over 200 million light-years away at the center of the Perseus galaxy cluster. It appears we don't know much about black holes. All we know for sure is that they consume and destroy everything around, whether it's a human being whom it'll stretch out like spaghetti or an entire galaxy with all the planets and stars in it. But as it turns out, that's not all they can do. Finnish scientists have recently discovered that some black holes can behave very unpredictably. For example, the black hole Maxi J1820+070, detected by astronomers, somehow lies on its side, and it's still unclear what made it turn like that. This black hole is in a binary system, meaning it exists next to another object, a companion star, which is gradually being consumed by it. Typically, in a space system where small objects rotate around a massive central body, their rotation axes must coincide. But not in the case of Maxi J1820+070. These are not the last spontaneous tricks of black holes. For example, in 2020, a drifting black hole was found, though we previously thought they didn't move. We know very little about these bloodthirsty space monsters. Scientists continue to study Maxi J1820+070 because it's still unknown how the hole's properties are affected by its inclination. Perhaps this way it can function more efficiently and capture more alien material, or even be able to release emissions over longer distances. It would have been a disaster for humankind. To our dismay, over the past 30 years, observations with the Hubble Space Telescope have shown that all galaxies have black holes at their centers, and ours is no exception. A black hole called Sagittarius A* is located at the very center of our Milky Way. Its mass is millions of times that of our Sun. So far, it's dormant and only occasionally absorbs gas or dust. But we can expect anything from it, given that the holes can bend and move. If such a black hole suddenly bursts into our solar system, its radiation will be so intense that you'll die right away. You won't even make it to the point where you start to get twisted and sucked into the black abyss. Still, think all these cosmic rays are too far away to affect a person? Tell me why your doctor can't comprehensively answer why you have constant headaches. Why do you often have eye irritation and sudden fatigue out of the blue? How many times did you get sick this year? Does it happen more often than in previous years? If you already feel that our ozone layer is getting increasingly worse at protecting our planet from space radiation, write in the comments. Thank you.